Okay, so for question one, they just give you the diagram, all right, but they didn't show you the length of the sides. So point P was the point 1, 1. So the x length is 1, the y length is 1, they are both positive, right? Because they're both on the positive sides of those two axes. So to get OP, which was the first question, you have to do pi tag. OP is the hypotenuse, so you do 1 squared plus 1 squared, and then you do the square root of 2. Then you use your triangle to get those three ratios. Guys, I didn't mention it yesterday, but I just want to reiterate, they're not asking you to find the angle. So don't find the angle, right? They're just asking for the ratio. So just the side over the side, that's it. Unless you have to simplify the fraction. Okay, but otherwise just the side over the side. So sine theta was opposite over hypotenuse, that's 1 over root 2. Cos theta was the same, adjacent over hypotenuse, all right, because this is a right and not a right angle. Well, yes, right angle, but isosceles triangle, right? So the opposite and adjacent sides were actually the same there. And then tan theta was 1 over 1. So guys, that's what I mean. Don't leave it as 1 over 1, please. You'll never leave an answer like that, right? 1 divided by 1 is just 1. Okay, so you have to simplify the fraction if you can. But you're not calculating theta. Lovely, you're not calculating theta anyway. Okay, if you did that, please draw a line through it, guys. Lose them off. If it's saying without the calculator and then you do shift tan 1, that's clearly calculated stuff. Okay. Any questions on number 2? There we have number 3. So number 3 was in the second quadrant. So they gave you point B was -3 and 4. So the x length is -3, the y length is +4. You again use pi tag to find OB, the hypotenuse. All right, and then you just use your triangle to get the ratios. Now, guys, like we discussed yesterday, angle theta is this whole obtuse angle, but you look at the inner angle of the triangle when you're doing your opposite hypotenuse adjacent. Okay, so sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Guys, remember we said in the second quadrant only sine is positive. Do we see that in our answers? Right? Remember when we did our diagram, when we started Trig in the confusion plane? In the first quadrant, all of them are positive. In the second quadrant, only sine. Which we see we're getting a positive answer for sine, but cos and tan are both negative. And it will always be like that in the second quadrant. Any questions on that one? Right, the last one, number 6, was a bit longer. You have to do a bit more calculations there. All right, so again, they gave you point C, which is x -12, and I'm showing you that that is in the fourth quadrant. So -12 is the y length. I think they put this on the diagram also. Oh, I actually have it here. Number 6, oh, they didn't, but they said in words OC is 13. Right, so they did give you that link, but it wasn't drawn on the picture. Then you need to use pi tag to get that side. It is a pi tag triple, guys. So you could have just said that x is 5, pi tag Pythagoras, so pi tag triple. And that would have been fine. All right, but that is the calculation if you have to do it. Now, guys, you didn't actually have to do this calculation for A. Because if you're looking at what they're asking you in A, they're asking for sine, right? And we already did have the opposite and the hypotenuse. Okay, so you didn't actually need your x side for A. Did we need it for B? For sake is the reciprocal of sine. So it's just that answer swapped around. So we didn't actually need this x value in B either. But now in C, when they're asking for tan is opposite over adjacent. So in C, you definitely need your x value. So guys, it's fine if your x calculation is only done in C. Okay, because that was when you actually needed it for the first time. I normally, when I draw my triangle, I know I'm going to need the third side eventually, so I calculate it straight away. But you can decide to only calculate it when you use it. Okay, they didn't actually ask specifically for x in the questions, but you had to find it, you had to use the x value. Are you guys understanding what I'm saying?
Yeah.
Okay. Right, then,
Is this number 6? Right?
yeah. Then D was another calculation, guys, sine B times sine beta, sine of beta times sine of beta minus cos of beta times cos of beta. So again, just if they're saying no calculator, which they doesn't actually say in this case. Oh, complete this exercise without the calculator. I didn't actually have. Yeah, so then you would have to show all these steps, guys. So you are finding sine, which we did actually find up there already, so that's not new work. Just have to multiply it by itself, and then cos beta, we actually haven't found that yet. So cos is adjacent over hypotenuse. All right, so 5 over 13 times 5 over 13. You multiply those together, negative 12 times negative 12 is 154, and 13 times 13 is 159. 5 times 5 is 25, and again 13 squared is 169. Now again here we have the same denominator, so you can just add the numerators together. And 144 plus 25 is 169. So then that answer is just that. Yeah, that's the question. Yeah. Fine, guys. Not fine. Maybe you see them not fine, but I'm not sure what's. Yeah, I'm not sure. There's no question. What happened? Okay, it's I understand. In terms of the work, in terms of number 6, are we fine with number 6? Okay. Guys, let me just quickly say something before I forget. I gave you incorrect information on the text, but it's good news. It's good news. It's still on the 26th, but it is not the next topic as well. All right, so wherever you made a note on what is in the text, it's actually a topic list, 2 topics list. So it's all the equations from last term and trig, and that's it. Okay, no inequalities and word problems like that.
So only equations and trig.
Only equations and trig, yes.
And this is
Yeah, please, thanks. Then you want to take a second more, please? You want to take I don't know.
you shouldn't even.
In text, Dad.
Oh, that.
Thank you very much. Hey, shush. Okay, guys, we are doing a new section today, special animals. All animals down tonight. And I got Cam going. And we got copy that for please. Equations and trig. Maybe we should give you just specific types of equations, but I'll just have to again and it will be a detailed list on classroom at some point. Alright, you're actually supposed to do it, but I think for timing something you should also. But it's equations and trig. I say inequalities and word problems as well, but that's not. We're actually only going to do that after the text. Okay, so sorry, that was my time. All right, special animals, guys, please write this down, copy this down. I know I'm a circle inside of the second triangle. We're going to do it all together. Does that first triangle look familiar? Isn't that the triangle we worked 4 times in the same continuum thing yesterday? The P60, and we have those same 3 sides.
So just like this. When you said it was on flow, then add minus negative root, add minus. Add minus.
Add minus.
For negative angle, what is the negative angle? How I know that when I move that? Yeah.
So getting negative angles are going to cost back. The element will not be the angles as one thing. Okay, guys, for these special angles, I just want you to make a note on the side. You are actually going to have to memorize these, but you actually don't need to memorize them. You can use the calculator. I'll show you now. You can use the calculator to set up your triangle. Okay, so there are certain angles where if they ask you to work with those angles, they're going to say without the use of a calculator. Right? Those angles are 30 and 60, 45 degrees, and then 0 and 90. Right? And when we do graph, we have go on. I'll show you next. You see the types of questions that they ask me. Right, now guys, this 60-degree angle or triangle, didn't we get this, was it yesterday, using the calculator anyway? Right, we drew our triangle, 50 and 60, and then we said, okay, what is sine 30? Sine 30 is a half. Then we said, okay, remember that sine is opposite over hypotenuse. So if sine 30 is 1 over 2, that will give me my opposite and hypotenuse length. And then we use pi tag to get it further. Okay, so guys, you can decide, are you going to do that? Because I'm not going to know whether you just type that into the calculator to set up your triangle or not. All right, or are you going to memorize this triangle? We're going to use it so many times in grade 10, 11, and 12 that at some point you are going to remember it, I think, without even thinking about it. So I always draw it in this orientation. I always put my 30-degree angle at the bottom. And then I just remember that the 1 is opposite the 30, and then I go around 1 to 3, like that. But then the 3 is just root 3. That's how I always set up mine. Now for 45, let's do the same thing, guys. Now I'm going to ask you not to do sine 45 and cos 45. Remember, it did actually come up in the examples that we did earlier. Let's just take a look here quickly. It was for this one, right? Here we have a 1 and a 1. This is an isosceles triangle, right? Now, if that is a 90-degree angle, what must both of these angles then be equal to if it's an isosceles triangle? 45 degrees. Okay, so this is actually our special triangle without us knowing it. Okay, I'm just going to repeat myself there. If that angle is 90, and we can see clearly that this is an isosceles triangle, right? Because these two sides are equal. Then, if that is 90, the sum of the other two angles must also be 90, right? Because the three angles in a triangle add up to 180. But if it's isosceles, then that angle is going to be equal to that angle. So they must both equal to 5 degrees. So this is actually your 45-degree triangle, right? You're going to do 45, 45, 1, 1, root 2. Okay, that's the 45-degree one. So yeah, 45, 45. And we're going to have 1 and 1, and then we're going to have root 2. That's an easy one to remember.
If you do from like sine 45, and it comes up with root 2 over 2.
Yes, which is not 3. So guys, if you use the calculator to set up this one, which is why I say don't do sine or cos of 45. See what happens? It says root 2 over 2. If we're using this triangle, what do we get for sine 45? 1 over root 2. Okay? I'm just going to write this at the bottom quickly. sine 45 from our triangle is 1 over root 2. But from the calculator, it's saying root 2 over 2. Now, guys, what's happening here, and this is something that we actually only do in grade 7, is that it's a different way of writing an answer with a rational denominator, they call it, where you don't have a square root, a surd in your denominator. All right, so we're only going to do this in grade 11, which is a bit irritating, but I'll show you quickly. If you want to get rid of a square root, what can you do to get rid of a square root? There it is. So instead of saying I'm going to square, can I say I'm going to multiply it by itself? It's the same thing, right? I'm going to multiply this by root 2. But guys, can I do something just at the bottom of the fraction? I have to do it at the top as well, right? Why is that? If I multiply the top and the bottom by the same thing, what am I actually multiplying the whole fraction by? 1. Okay. So guys, you can't square the top and square the bottom. That's not the same thing. Okay, because if I'm squaring the top, I'm multiplying it by 1. And if I'm squaring the bottom, I'm multiplying it by something different. Okay, so we're not squaring the top and squaring the bottom. We're multiplying the top and the bottom by the same thing. In order to get rid of this square root, I need to multiply it by itself. So that is where the calculator is getting root 2 over 2 from. So the calculator will always give you an answer that doesn't have the surd in the denominator. Okay, so if you're just wondering, why is the calculator bringing something else up? Even if you just type this in, guys, if you even just type in 1 over root 2, it brings up root 2 over 2 straight away. Now guys, these two triangles, the reason why we have to write 1 over root 2, the reason why we have to have 1 and root 2. The reason why we have to write it like this, do we remember the concept of similar triangles?
Yeah.
What are similar triangles?
Yeah, triangles that have like the same side angles but are different sizes.
Yes, we remember that, okay? Triangles that are similar are triangles that have the same 3 angles, but they can have different sizes. All right? So if we're thinking of these are almost like the base triangles, the most basic triangles with those 3 angles. So if we're looking at the first one, if you have a triangle with a 30 and a 90 and a 60-degree angle, the sides will always be in this ratio, right? Where the side opposite the 30-degree angle will be in the ratio of 1. The hypotenuse will be in the ratio of 2, and that one will be in the ratio of root 3. So you can, don't write this down, but I'm just going to show you. If we're doing similar triangles, right, we can say, okay, those sides will also be 3 sides of a triangle with those same 3 angles. So if I have 2, 4, and 2 root 3 as my 3 sides, those 3 sides will be in proportion with these basic 3 sides. You guys remember sides and props, okay, from similar triangles. In the same way, I can say, if I have these 3 sides and I'm going to multiply all of them by 3, so 3, 6, and 3 root 3, those will also be 3 sides of a 30, 60, 90-degree triangle. You can also multiply them all by 4, or by 5, or by half, all right? If you are increasing them or decreasing them in the same ratio, they will change in size, but their shape will stay the same. The angle will stay the same. So guys, this is what I'm trying to say is that this is the base triangle with those 3 angles. 1, 2, and root 3. Those are the smallest sides, all right? If you have any 3 sides of a triangle, you will always be able to simplify them to those 3. So this is the base triangle. It's the same with this. This is also the base triangle of a 45, 45, 90 with 3 sides. Okay, so these are the sides. Guys, if you're going to write root 2 over 2, you're going to get 0 because I'm going to know you use the calculator. Okay, so you have to use this triangle and you have to write, if they're asking for sine 45, you have to write 1 over root 2. If you are writing root 2 over 2, I'm going to say, oh, they typed it into the calculator, 0. Okay, you'll see now how we're going to ask you how to do it. Then I will make it clearer. All right, then the others are a bit complicated because they're not actually triangles. So I don't know how you guys are going to deal with that. You'll see now on that order. Okay, so number 3
All over the way.
Is 0 degrees? No, it's not. It's just
Oh,
not a
one
triangle.
line.
Yeah, exactly. All right, so 0 degrees. So now, guys, you're just gonna have to bear with me on this one. I want us to draw a Cartesian plane, just a small one. Just a small one. Yes.
I see, I see.
Oh, guys, yeah, 0 degrees is there. So just draw a line like on top of that x-axis. And we are going to say that this line ends at the point 1, 0. Yeah, I think so too. All right, now guys, if you can imagine that represents a triangle. When we have a triangle with 3 sides, right? We have the hypotenuse, which is the actual length of this line. Now guys, what is the length of this line? What do you think? 1. Okay, so let's put there that R is 1. Do we remember that when we did Trig on the Cartesian plane, we said that the hypotenuse can be represented using an R. That's like the radius of a circle, right? If you draw a circle all the way around. The R is 1. If you want to, you can just put in brackets the hypotenuse. So that line is our hypotenuse. Yes. But that line is also the adjacent side. So we have a 0 degree angle over here. Hey, can we see that angle there? Can we see that angle? So the adjacent side is also the same side as the hypotenuse. So this side is actually adjacent and hypotenuse at the same time. Does that make sense? It's like a flat line. Remember this line here on the x-axis is always the adjacent side. But now because it's on the axis, it's also the hypotenuse. So the adjacent side, that is the x side, right? X is 1. That is adjacent. And guys, what is my opposite side? Is there even an opposite side?
No.
So what's the length of that opposite side? 0. 0. Good. So y is equal to 0. That is the opposite.
Ma'am, could you think of it as like flattened triangle, basically,
Yes.
like
Yeah.
the hypotenuse is just gone.
Yeah, exactly. And guys, we do actually get the x and the y lengths we get from this point. Right? If you remember that point 1, 0, then you can get it from there. So now what does this mean? You guys have been asking me, why is sine 0 equal to this? Why is cos 0 equal to this? And I've been saying, just hang on, we're getting to it. We're going to get there. So now we can say that sine of 0 degrees. What is sine again? Opposite of the hypotenuse. So 0 over 1, which is what? What is 0 divided by anything? 0. But guys, if you type that into the calculator, sine 0, it does come up with. Let's do the same thing for cos of 0 degrees. Now cos is adjacent over hypotenuse. So 1 over 1, right? 1 over 1. So cos of 0 is actually that 1, which is also what you get on the calculator when you type it in. And then tan of 0. Yeah.
Oh, sorry, I was actually off something.
Okay.
That's why I was. Opposite over here. So you're.
Over 1, yes, thank you.
I was wondering that. I wasn't ready for that.
It's fine, you did well. Yes.
Process and oh, they just not.
There will be answers. So guys, we can write that down as well, right? If we're doing the reciprocal, sorry, I'm just moving across. So what is the reciprocal of sine again? Cosec So cosec of 0 is going to be the reciprocal, right? So 0/1 we would swap around, 1/0. And now we remember that we can't actually divide anything by 0. Okay, so if they ask me for cosec of 0, that is going to be undefined. Anything divided by 0 is undefined. What about sec of 0? That's just going to be 1 still, right? Because if you swap 1/1 around, you're still getting 1/1. But then cot of 0 degrees has the same thing that happens there because tan was 0/1. So cot is also going to be 1/0. So that is also going to be undefined.
So basically, like this 0 degrees triangle is like the base of all triangles. All made up.
All 0
And
triangles.
that's where, like, similar, like, sine like proportion of the ratio.
So guys, let's just quickly talk about that. Even if I had a 3-0 point here, right? Say instead of using 1-0, we decided that we were going to use 3-0. Your hypotenuse would then be 3. Your x value would then be 3, and your opposite will then be 0 still. Right? So I'm just saying, if you didn't use 1-0, if you used a different point, right? And you then calculated all of these ratios, you would get the same answer because you would have 0/3, which is still 0. You would have 3/3, which is still 1. And you would again have 0/3, which is still 0. Okay, so we work with the simplest possible point, 1-0. Why not? Why complicate things, right? Let's use the easiest point to work with, 1-0. A point on the x-axis. Okay, the last one, number 4, is similar to this. It's a 90-degree angle, which we're calling a triangle as well, just because we're working with Trig. So guys, if you can just draw that same Cartesian plane, please.
Why are triangles like this? Like, why would you get?
Feel like a little table.
Trig gets used all over the place in engineering, in science, in sound engineering. I mean, I'm not a doctor, so I don't know, but I've spoken to people. I know Mrs. Smith used to be an engineer. She used Trig and Trig graphs. Yeah. She was, All right, guys, you are drawing a 90-degree angle there. So this is now 90 degrees. And this point is now the point 1-0. Oh, 0-1, thank you. Thanks. Okay, 0-1. It's on the wire. But instead of thinking of this as a triangle, we can just think of in terms of this line. What is the length of this line? The length of the radius. The length of that line is 1. Okay. What is the x value? 0. The x value of that actual point is 0, right? And the y value is 1. Remember that r is the hypotenuse. Your x value is always your adjacent side. It's fine, that happens. And the y value is the opposite side. Okay, guys, let's quickly do the values for this angle.
We can say that basically this triangle is gone from like this to this. I like visual.
Okay, guys, side, opposite, of hypotenuse. 1/1. That is why when you type into the calculator sine 90, the answer is 1. Cos 90. Adjacent over hypotenuse. 0 over 1. So 0. Tan 90. Tan is opposite over adjacent. 1 over 0. So tan of 90 is actually undefined. And guys, I am making a big deal out of these values because tomorrow we're going to draw 3 graphs and we're going to use all of these values on the graph. Okay, so yeah, that's why I'm making sure that we write all of them out. Let's quickly do cosec, sec, and cot. Cosec 90. Still 1, eh? When we swap those around, we still get 1. Sec of 90. Undefined. And cot of 90 is going to be 0. Yes. Because that doesn't be good. There's no answer. How can you divide it by 3? It's not that that doesn't exist, that's the answer that so the thing that you divide it doesn't exist. But the answer, like you can't divide it like that. Is there no like trick that we'll learn one day? Like we thought like most polynomials can't be background design, they can. Nope, there's no trick. Okay, now guys, I just want to add a little note here. And we did actually write down all of these values, but we can easily calculate them, right? We are going to do it now in the examples. Here, whenever they are asking you a question that includes a 30 or 60-degree angle in the question, you are going to have to draw this triangle on the side. You actually get a mark for drawing this triangle. All right, so this triangle, you have to be able to draw in a question, in a text or exam. All right, you need to draw this triangle, which is why I'm saying you must memorize it. So when you see there's a 30 or 60-degree in your question, anywhere in the question, you're going to have to draw that triangle. And it's the same for this one, a 45-degree triangle. If they are putting a 45-degree angle anywhere in the question, you have to draw this triangle and you'll get a mark for it. The 0 and the 90, you do not have to draw. So you will not have to draw the second, well, number 3 or number 4, you will not have to draw this.
In text, if they ask us
50, 60, or 45, you have to draw those triangles. But if they are asking you about 0 or 90, you do not have to draw them. No, they won't ask you about other ones. There are no special triangles. You can draw it if you would like visual representation. Yes. Yes. That's no problem. Okay, we're going to do an example now, guys. We can see how this is actually going to be asked, all right? Because we haven't done like proper examples yet. Okay, so are we? Yes, basically. All right, so that's it, guys. We're going to move on to the next page. Are we fine? It's happening. All right. Something have such a like spatial awareness. Where was like I think it was with so traffic. Yeah, it's irritating. I don't want to find out. Okay, thank you.
Can you go back to the
You remember how I was always fumbling? Oh, where's this page? Where's the homework? Where's the thing? Oh, it was. Sorry.
I'm worried that maybe I'm some of the new kind of
I have a folder currently teaching. And all the stuff that I'm currently teaching.
I can't find anything on my stuff. Same password, swear to go.
But if it's exhausted, if it's just miraculously disappeared.
It would be, yes, you'd see me in proper tears if that was happening. Is it insured? No, it's not.
How do you get sick if I lose my folder? You guys are you'd be bad when I talk this. What does that mean? You go fine. Maybe I don't know. Maybe if you
Now you can take my sales.
you have better pay on my 2 months of right now.
All right, there we go. Calculate by using special angles. Or they can say, I'll just add here in a different color. Or they can say, without the use of a calculator, calculate that, all right? But if they're saying using special angles, then we know that we need to draw those triangles. So without the use of a calculator, right? If that instruction is there, it's the same type of question. So guys, now we notice that there are two 45-degree angles in this question. That means on the side, you're going to have to draw your 45-degree triangle, right? You only have to do it once in a test or exam, guys. So if in the next question, there's again a 45-degree angle, you don't have to draw the same triangle twice. Okay, you're only going to draw it once and you then use it. So let's do that, guys. Let's draw this 45-degree triangle. It doesn't have to be to scale. Don't worry about it looking like an isosceles triangle. It really doesn't matter. All we want to see is the actual values on and in this triangle. Okay, so we need to put a 45-degree angle in each of those angles. All right, so 45 degrees and 45 degrees. And now remember, we're drawing the base triangle, the one with the smallest side. So we're doing 1 and the square root of 2. Guys, if you just remember 1 and 1, you can find root 2 by using pi pad. Okay, so if you just remember that for this 45-degree triangle, it's isosceles. So we're using the shortest possible line, we're using 1 and 1. And then to get the hypotenuse, you're going to do 1 squared plus 1 squared, which is 2. And then the square root of that is the square root. Okay, so you don't have to remember all three of them, but I don't think it's that difficult to remember those three sides. Really not that bad. Now, guys, you're going to use this triangle to solve this question. So sine of 45, you're going to look at your triangle, you're going to do opposite over hypotenuse. And because it's saying sine squared, we need to square that. All right, so sine 45 is 1 over root 2 squared. And guys, this is what I was talking about earlier. If you have this triangle, right? But you're writing root 2 over 2, that's a dead giveaway that you use the calculator. Okay, so if you are typing into the calculator sine 45, remember we looked at it earlier. If you're typing sine 45, root 2 over 2 comes up. If you are writing root 2 over 2 here, but this is your triangle, the marker is going to know that you use the calculator. Okay, so don't do that, please. You have to do 1 over root 2. Plus, cos 45 is the same, actually, right? Adjacent over hypotenuse. 1 over root 2. And then we're squaring that as well because it's cos squared. And now it's no calculator, so we have to actually show how we're solving this. It's not that bad. 1 squared is 1. Root 2 squared is 2. Plus the same thing, right? What's a half plus a half, guys? So the answer is 1. Guys, you can check your answer after doing the question. So you can now in the calculator type sine 45 squared plus cos 45 squared, and that does come out as 1. Okay, so that you can check afterwards, but you're not supposed to use it with any word. Are we fine with that first one? Now guys, marks here for this, 1 mark for the triangle. Right, so if you don't know how to do the work, you can at least do the triangle and you'll get a mark for that. You will get 1 mark for each of those values that you're subbing in, and then 1 mark for the answer. So that is a 4-mark question, right? 8% of the text. That's not bad. Okay, number 2. Tan squared 45 degrees.
No one's really ready to click now, but I see that like time clock is done already.
Yes.
I was thinking, I know.
It does take a while for it to be something completely like abstract. It's not-
That's a scary idea.
Okay, guys, let's do this one. We already have a 45-degree triangle. I'm not going to draw it again, but now we see that there are 30 and 60-degree ratios there as well. So now we also need to draw the 30-60-degree triangle. So again, just on the side, I'm going to draw that. It doesn't have to be to scale. You are just drawing a right angle triangle and you are filling in the values.
Yeah, do we have to draw another 45?
No, I said already, if you've already drawn it in a previous question, you don't have to draw it again. Okay, so we have 30, 60, and 90. And then we're doing 1, 2, root 3. Okay. And guys, if you're doing my 1, 2, 3 thing, how do you remember that this bottom side can't be 3? It has to be the square root of 3. Do we remember that in a right angle triangle, the hypotenuse always has to be the longest side? Do you remember that? Hypotenuse is always the side opposite the right angle, which is the biggest angle in the triangle. So the longest side is always opposite the biggest angle. I don't know if you guys know that. Right? In any triangle.
Yeah.
The longest side is always opposite the biggest angle, and the shortest side is always opposite the smallest angle. So if we're looking at these values now, the smallest angle is 30, and 1 is the shortest side of the 3. So the 1 always has to be opposite the 30. 2 is the longest side of these 3, so the 2 has to be opposite the biggest angle in the triangle. And then root 3, when you type it into the calculator, is 1,73. So that is the middle side, right? That's between 1 and 2, 1,73. So that has to be opposite the middle angle. The angle that's not the smallest or the largest. So that's between that. But I always just remember 1, 2, 3, but then this one has to be the square root of 3 because this side can't be bigger than the hypotenuse. Okay, so it can't be a 3, it has to be a root 3. Okay, back to the actual question. So now tan squared 45. Guys, tan 45 is 1, am I right? Let's go back up to our 45-degree triangle. 45 tan is opposite over adjacent. So tan 45 is 1. So this is going to be 1 squared, which is just 1. So you can write 1 if you want to. Plus sine 30 opposite over hypotenuse. Sine 30 is a half.
Is it okay? Yeah, I wrote whatever one.
Yes. Cos 60, we're looking at the 60-degree angle. 60 is adjacent. Sorry, cos is adjacent over hypotenuse. So cos 60 is also a half. Now we need to work that out. We have 1 plus a quarter. I suppose it's a very simple step. You know, it probably would have been fine if you didn't actually write that down.
Only work, or it was only look out on answer. Is it angle with the, an angle?
There's some relation. All right, what's 1 plus 1/4? If you want to write it as an improper fraction, that is 5/4. But guys, if you want to, you can write 1 1/4 as a mixed number. That's fine.
With some of the,
Or 1,25 even, if you want to do that, it's fine. Okay, now guys, you're gonna probably shout at me now, but if they're asking you about, don't shout before I've even said it, wow. If they're asking you to find, if you have a question like this, right, and it's 0 and 90 degrees in the question. Like I said on the previous page, the 0 and the 90, you don't have to draw that. So, no one's gonna know if you actually just. But I'm not supposed to say that.
okay, now you said that.
I'm just doing a little.
Yes, checking if it's like still,
Yes,
okay.
you can check it on the calculator and then write it down if you want to do that.
And then you just.
Okay, so for 0 and 90, you don't have to show any proof that you're not using the calculator, so no one's gonna know. Yes, no? How do you know which angle is which? So you have to look at the angle that they're saying, right? So if they're saying cos 60, then you look at the 60-degree angle and you're going to choose the adjacent side to that angle. Okay, so they tell you in the question which angle to look at.
The 90 and the 0.
So they are very much. Say again, please? Oh, you can decide. I always draw my 30-degree angle at the bottom. But guys, if you're swapping your 60 and your 30-degree angles around, then those two sides also gonna have to swap. So it's important that you just remember that one always has to be opposite the 30 degrees. So if you're putting your 30-degree angle at the top, then that one is gonna have to be 1. Okay. So those two must always be angle and opposite. The 1 must always be opposite the 30. Yeah, I always put the 30 at the bottom, but you can swap them around if you want. You asked me to do an example of a 0.
And the 90.
This is how you run.
Yeah, how would you, how would I get out?
Okay,
Like what?
so just like these ones, so they can just say, for example, let's do sine of 90 degrees plus sine of 30, just a very simple one. Guys, like I said, you don't have to show any evidence of where you're getting sine 90 from. We know in our heads we're looking at that angle, hey? Yes, we're looking at that one, this one. Okay, so in our minds, we're thinking of this. Yes, wonderful. On the page, all you have to do is write the value. Okay, so sine 90, can we remember what that was? Sine, remember, was opposite of hypotenuse. Yes, sine 90 was 1. But guys, what I'm saying is, I'm not gonna know if you have any people.
Yeah, we'll be allowed.
Yes, you always have to have a calculator in the face, yes. And then sine 50 for this one, use the triangle, but we've already drawn the triangle. So we're not gonna draw it again, right? So we go up to the one that we've already drawn. Sine 50 is opposite over hypotenuse, 1/2. So that is a half. So what is my final answer? 3/2 or 1.5 or 1.5. You can decide how you want to write that.
Can we leave it in improper fraction?
Yes.
And then can we just do
But let me just write here for this. Do not need to draw a diagram. So for the 90-degree one. And the same thing for 0, guys. If it's 0 and your question, you also don't have to draw that diagram.
So with diagrams for 45 and 30, it's X, and they will use the 30 and 60. Only have to do it. And if one of the questions for this actually just 8 based on a lot.
Already drawn it once, you don't have to draw it. So what a lot of people do is if they know there's gonna be trig in the page, they even draw it right like on the front page.
That's so
And they
smart.
just refer back to it. Yeah, it doesn't have to be.
So
in the
there's your
specific
mark
page.
track.
You can't want to.
No, I need to be able to see it in order to give you a mark, so you have to do it on your screen. Okay, guys, I would like you to do this whole exercise. It's a number 1 and 2. We have already calculated some of the values. So the first question is saying complete using the diagram. They're giving you a table, sine, cos, and tan of all the special, and cos, except and cot of all the special angles. Okay, we have already written down a whole bunch of them. You don't have to draw them in the table again, guys. You can just list them. Okay, I know sometimes it's a bit of a mission drawing a table and filling it in and getting the spacing right. You can literally just write them down. And then for number 2 is calculations, like we just practiced.
Now, if I'm, like, I know what, like, I sometimes.
Exam.